Welcome everyone to the What's New breakdown for Moldex3D 2021. Today we'll get into UI enhancements, solver enhancements, new pre- and post-processing tools, new meshing tools, and many other user experience improvements. So let's get started. In the UI or user interface, users can look forward to left-click dragging to be able to rotate. This can be especially useful when coming over from CAD softwares that utilize that sort of mouse interaction. By default, the right-click drag is still going to be rotate, but if you deselect this toggle down at the bottom right corner of the screen, that will enable you to left-click drag. This disables the selection function, so you'll want to toggle this on if you want to select an object. Drawing lines has gotten a lot easier in Moldex3D 2021. The ortho snap down here at the bottom right corner of the screen allows you to snap not only in the XY plane anymore, but also includes the Z axis. So if I'm drawing a line, I can still use the XY plane for my ortho snap. In this case, the XY plane can be indicated down the axes, but I can also snap to the Z axis as well, giving us all three axes and making our line drawing life a lot easier. The region zoom function up in our user interface toolbar allows us to zoom in on a particular region of our geometry without having to manually scroll in and out. When selecting an object, the object will select in yellow, just as in the past, but the feature lines will now show in black. This gives a little bit more visibility as to the features on the geometry when it is selected, and makes your life a little bit easier when you're trying to discern certain features from others. After the simulation is completed, the indicators for the different result sections are much clearer. You have a green F for filling, an orange P for packing, blue C for cooling, and red W for warpage. When looking at warpage results, users can specify their own coordinate system rather than just the World Coordinate System WCS. A new coordinate system can be added based on 3 points. Those are some general quality of life improvements, so let's jump into the Home tab. In the Home tab, the first thing that you'll see is that there's a new item called Result List. Result List allows you to customize what results are shown in your result menus. There are a multitude of results that show up under the filling results, for example, but if I don't care about some of these results, or if I want to focus on some results over others, I can create my own customized result list, and only those results that I choose will be shown. And they'll also be shown in the order that I select them. You can go back to the default Moldex3D result list at any time. Under the Import Geometry function, there's a new option to swap geometry. Swap geometry can be used if there's a minor modification with the molded geometry. Swap geometry simply allows you to delete the existing object and replace it with the new object, carrying over all of the attributes and node seedings that are associated with the current geometry. This can make things a lot smoother when you're transitioning between different designs. A functionality enhancement has been created for the process wizard. You can not only view your process wizard, but you can also create a new process file directly from the UI, rather than having to create a new run. You can also edit and go into a view-only mode if you so desire. Jumping over into the Model tab, when you place a gate or create a runner in Moldex3D, there's a new path length function that will give us the distance along the path lines to get from your melt entrance to the gate. For a multi-cavity system or a multi-gate analysis, this allows you to geometrically balance your gates without having to measure them manually. Want to add a nozzle to your analysis without going through the effort of looking up what the nozzle should look like? Well, we have the new nozzle zone function that allows you to create the geometry of the nozzle inside of Moldex3D. All you have to do is click Nozzle Zone, click your Melt Entrance, and it will show you the geometry as a wireframe. And you have a bunch of different options here that you can select between. Once satisfied, you press OK, and it simply creates the geometry for you. Jumping over into the Mesh tab, the first thing that you'll see, the seating function has now been moved in front of the Generate function to facilitate the left to right progression of steps through our interface. The new functionality, Sync Seating, allows you to sync the node seating between two different geometries. So if you have a multi-cavity mold, you're able to specify the Goldilocks seating on one object and then copy that to another object, for example. Or if you've done manual refinement on specific features of your geometry, you can copy all of that manual node seating over to another geometry rather than having to do it more. This can significantly cut down on the amount of time that it takes to manually specify the node seating across your geometry. As far as service meshing goes, there are a couple of new functions that have been added. The first is Project Nodes. Project Nodes allows you to project the service mesh nodes from one object to another. The new Fix Aspect Ratio function goes through your geometry and cleans up as many aspect ratio issues as it possibly can. Jumping over into the Tool tab, there are a lot of improvements to be expected under the Tool tab. We've included a lot of CAD functionality. First of all, under the Points section, we have a new function, Volume Centroid, which allows you to simply just select a volume, typically a polysurface, and it will create a point at the volume centroid for that object. Under the Line dropdown, there are two new functions. First of all, Circle allows you to just create a circle from a given point. And Interpolate Curve allows you to create a curve through multiple points. This will make conformal cooling that much easier. Explode Curve allows us to explode the segments of a line. For example, if I use a multi-line, that line does not have to be one single object anymore. I can either join all three of these curves together using the Join Curve function. And then if I don't want those connected anymore, I can simply explode it. Bridge Curve allows me to bridge 2 points on 2 different curves. This can create rounds, and this can also be used to generate hoses or external connectors to the mold. For example, if I have 2 parallel lines, I can use the Bridge Curve function to select the 2 ends of the lines, and it'll create a semicircular connector. This connector will be its own line-defined object, which can be assigned as a hose. Creating center lines has gotten a lot easier with the new Central Line tool. Central Line takes a cylindrical object and creates a center line through it. This can be one continuous object like this one, or it can be a series of cylindrical objects that are separate from one another. Central Line will take one geometry, and it'll simply create the center lines. This will vastly simplify the cooling line generation process, making it that much easier to use the line-defined sort of meshing method. If 2 objects are misaligned with one another, you can use the Orient 3-point under the Move dropdown to orient 2 surfaces to one another. So I select my object to orient. Reference point 1 is 1, 2, 3. Target point 1. Make sure that these match up. 1, 2, 3. This can be particularly useful when taking a model from your assembly file and importing it into your mold file. The new and improved Extend function allows you to extend a line in either direction parallel with the line's current orientation. Previously, the Extend tool extended the line in a in a specified direction, but that could be a little bit difficult to specify. So instead, we're keeping the orientation of the line stationary and only allowing you to move one endpoint. Just to show you how that looks, you'll use a boundary object to specify the orientation of the line, and then you'll click on one curve that I want to extend. The reverse curve function will allow you to reverse the reference ends of a particular line segment. So I can choose my runner line, for example, and I can click on any of these arrows to reverse the directionality of the line. Move curve end allows you to customize the contour of a line segment. So if I create a random line in space, I can use the move curve end to specify where that curve should be going. This can be used for interpolated curves, bridge curves, or straight line segments. Jumping over to the Result tab, a few new animation styles have been added. So for a melt front time, I can use a particle tracer simulation or an animation in the interface. If you've run the particle tracer animation, you'll be able to actually play this animation and export the particle tracer animation. Keep in mind that you can also trace these by lines to make your animation a little bit clearer. The particle tracers, as always, can be enabled from the computation parameters using the checkbox down towards the bottom. The other improvement comes in the compare function. We've given a lot more sync options rather than just sync rotate, sync result, and sync range. You also have a multitude of other sync options available to you to make your viewing experience and make the compare tool a little bit more functional. Looking at some other improvements, the calculation speed has increased for parallel processing. Looking at some different solid mesh element counts, we can see that the difference between 1, 16, and 32 has been a little bit more optimized. For 16-core computing, you can get up to 2 times faster simulations, and with 32-core computing, which previously the speed-up ratio was not that high for 32 cores, it is a little bit faster now, giving the 32-core option a little bit more benefit. In addition to the processing speeding up, the speed of importing your model and loading your results has improved by over 90%. This means that your models will come in faster and your results will load a lot quicker. A new enhancement has been made to our warpage calculation, what we call the SPS, solid state properties for shrinkage, considers the solidification effect during the packing and cooling stages. This is an empirical rule to account for the physical behavior based on some numerical experimental evidence. Previously, the viscosity model's extrapolation would make the slope a little bit smoother with respect to the main viscosity curve, but now as the material reaches the freeze temperature, the viscosity goes more towards infinity. This will improve the solidification behavior during the packing and cooling stages and will make the warpage calculation that much more accurate. For those of you using fiber-filled materials, we're now using a little bit more realistic of an approach for the calibration of the mechanical properties of the original melt. Previously, we used the experimental mechanical properties, things like the tensile modulus, shear modulus, CLTE, and many others. But those are representative of an ideal circumstance. In reality, we don't have an ideal fiber orientation. There is going to be a distribution of moduli throughout the material, and this calibration will allow us to get a little bit closer to the real material molding condition. The new buckling analysis in Moldex3D is a linear buckling analysis to provide a potential that stress will cause the buckling behavior during warpage. The output of this buckling analysis will be a series of eigenvalues telling us what the probability of buckling in each direction or in each buckling mode is going to be. This will output the potential buckled model. The capillary underfill process as well as the potting process are now able to be visualized in Moldex3D. These can also be extrapolated to include things like 3D printing. a feature that we'll be including in one of our future versions. Some enhancements have been made to compression molding and injection compression molding alike. The generation of a compression zone is much easier now using a tetrahedral mesh. Any sort of mold insert or even complex compression zone can be generated intuitively. And the shape of that compression zone will actually deform the melt in the expected manner. Gas-assisted and water-assisted injection molding now have the capability to include an overflow valve. This overflow valve can be controlled very similarly to a hot runner valve pin. And then for powder injection molding, we've improved the stability of the solver and it gives a more clear concentration distribution to allow users to visualize the aesthetic defects a little bit cleaner in the interface. The DOE function now allows us to include flatness and roundness, as well as linear shrinkage as a quality factor. And last but not least, the Studio Viewer now allows you to export a viewer file rather than having to share the entire project file. This MRMV file will be about 20% the size of the actual run. This will decrease the amount of time that it takes to share files from the simulation engineer to colleagues with the Studio Viewer, and will make communication that much more efficient. Thank you everyone for watching the What's New breakdown for Moldex3D 2021. You can watch all of our other tutorial videos on our YouTube channel Moldex3D North America, and you can follow us on LinkedIn to be notified when new videos are available. Thank you for watching, and go beyond simulation with Moldex3D.